Hello again. So this is a circuit designed to turn on one of these two LEDs for a certain amount of time every time this pressure switch is triggered or pressed. The way it works is these components right here and this chip, which I'm only using one of the gates on, is a debounce circuit. Debounce is important because normally when you turn a switch on or off, if you look at it on an oscilloscope, it's not just a pulse, it is a pulse in a whole bunch of jaggies. Kind of like your heartbeat, it goes up and down. And when it does that, it can freak out other electronics components. So a switch debounce circuit is necessary. That goes over to this flip-flop, which is this chip right here. These are 4013 flip-flops. I have 3 of them. This flip-flop just has 2 outputs, Q and not Q. They go, they alter states. When one's 1, the other is 0. And vice versa every time I push this button. When that happens, it goes to these one-shot flip-flops. Each of these chips has 2 flip-flops in there. So I'm only using one here, but here you have to use both sides. So you use 2 flip-flops for each of these. A one-shot flip-flop is every time it's triggered this input, which is this wire and this wire, they go in and trigger a process so that it turns on, and then the RC timeout, or the RC pair here, causes a timeout, which then discharges and turns these LEDs back off. Otherwise, they would be like a railroad sign. They just go one, the other, one, the other. Problem is, I don't want that. This is going to be used for my Zod saber. That is this little thing over here, the saber that pops out of his right arm. I'm doing it much like a lightsaber would. It's all flexible plastic. I'm not too concerned about it. This just comes out. See, this is real bendy. Anyway, this will extend out from my arm, but I have to have a motor to do that. And that motor, which is actually downstairs, is going to be connected to some mechanics there to push that out and pull that back in. But to do that, I don't want it to be on all the time. I don't want it to be off all the time, or pushing out or pulling in all the time. That's why you have to have this one shot so it runs for a little bit and turns off. These other 2 chips down here, I could get away with just this. These other 2 chips are actually some logic gates that make it dummy proof so that only one of these can be on. Because if they're both on, you'll fry what's called the H bridge, which is 4 transistors that are hooked up to control the motor direction forward or reverse from 2 inputs, which are the 2 inputs, right here, the black and brown wire. And with those 2 inputs, you don't want them on at the same time, because if you do, you fry your transistors. So what we're doing is dealing with the sunlight going away, of course. So the way this works is here. I'll press that. There's one LED. Wait for it to time out. Press it again. There's the other one. So that'd be like retract and extend. Each time I push this one switch, which will be hidden up in my gauntlet, I'll just put it up here and I'll just go and squish it against my knuckle. And I'll just turn this on and off. Now, I don't necessarily need these circuits. I can get rid of them, and I think I probably will to save space, because I don't have a lot of room. I've got to build a cowl that goes over this, which is going to hold all this. And actually, it's fairly large, so I should be able to get a small circuit board in here. And obviously these are big loosey wires and all these big loosey leads. They'll all be trimmed down. They'll fit flush on the circuit board, but still. I've got to get them all in here, and these 2, all I got to do is just replace that with the cable and just not plug in the motor until, or the H bridge. Actually, it'll be 2 cables, one from here to the H bridge, and then from the H bridge to the motor. I'll put a schematic up at the end of the video, and also on my Facebook page, facebook.com/Eric Browning Cosplay. So you should be able to get a sense of how that actually works. I tried to document and outline things so you know what's going on. All right, thanks a lot.